Hello students, welcome to section 4.7 continued. We're going to begin here by looking at example 2, and we're going to evaluate the following equation. Y equals inverse cosine of root 3 over 2. So as we've already discussed, the inverse cosine of any ratio of which has to first fall between -1 and +1. The inverse cosine of which should end up only being an angle that falls in either quadrant 1 or in quadrant 2. And just to reflect, as we can kind of see here from our table from up above, again you can only do the inverse cosine of a number between -1 and 1, and the result will only be an angle between 0 and pi, technically between the first and second quadrants. So if we take a look, we're going to go ahead and do the analysis and technically try our best to do so without a calculator. So what I encourage us to do, first and foremost, is to identify that yes, it can only be in quadrant 1 or in quadrant 2 as far as how the calculator would interpret it. Now I say as far as how the calculator would interpret it, remember, there are an infinite number of answers of which have an x-coordinate that's root 3 over 2. But we want to limit it to such an angle that has, again, only one particular version, or one angle that is of one version. Alright, so what we do in evaluating, we denote that it's quadrant 1 because root 3 over 2 is in fact positive, not negative. And then we think what angle in the first quadrant has this x-coordinate. As I uncover, we can already start to see here, as I continue to uncover, pi over 6. Pi over 6 is the only angle of which has an x-coordinate of root 3 over 2. As you can see in my graphical depiction, I've also shown how we can, I would argue, nicely convey graphically that an angle both in the first and in the, let's see here, I want to delete that, first and also the fourth quadrant could be an answer. As it turns out, there's another angle in the fourth quadrant. If we think about 1/6 of pi, 11 pi over 6 is another angle that has the exact same x-coordinate. The problem, of course, is that 11 pi over 6 is not in either quadrant 1 or 2. Quadrant 2 is certainly not an option because this is not a positive, it's a negative, pardon, it's a positive ratio. So the only answer that makes sense here is pi over 6. Now if you were to in fact type in cosine of 11 pi over 6 on your calculator, you should in fact get root 3 over 2. But again, we're finding one answer by virtue of the inverse cosine being limited to those two quadrants. Now the next problem you already see, I've uncovered the inverse tangent of 1. Can only be found in either quadrants 1 or 4. We talked about, again, prior to this, we talked about how inverse tangent, you may plug in any value as a ratio. However, your answers will only fall between these two values, but not including -pi over 2 to +pi over 2. Unlike the inverse sine where it can include those two values, inverse tangent cannot. As you remember, hopefully, there are horizontal asymptotes at -pi over 2 and at pi over 2. So for this particular problem, we know that either quadrant 1 or quadrant 4 will have a tangent of an angle equal to 1. So the inverse tangent of 1, of which we know in quadrant 1 has a positive tangent. Quadrant 4 is another option for us. However, particularly with regards to this range denotation, negative to +pi over 2, the problem is quadrant 4 will never have negative tangent, so only quadrant 1 makes sense in context. And then I've denoted the angle, as you can see, which I'll start to uncover even more. It has to be pi over 4, because only pi over 4 has a sine over a cosine that, because they're both root 2 over 2, equals 1. The x and y coordinates are the same. So if you take a look at the graph again kind of speaks for itself, I would argue. If we take a look, the tangent of pi over 4, again the y coordinate, in other words the sine is root 2 over 2 divided by the x coordinate, the cosine also root 2 over 2, it equals 1. It is also true that an angle in the third quadrant, of which we can consider as what, 5 pi over 4, also has a tangent of 1. The problem of course, with that is that we agreed at the beginning that only quadrant 1 or 4 could be answers of which an inverse tangent is placed. So in this particular case, again, considering what the calculator would be giving us, technically it would only give us one answer in quadrant 1, pi over 4. Just to double check, if you did in fact do tangent of both angles, why don't we try that here? And I'll make sure that I'm in radians. If in fact we are in radians and do the tangent of both pi over 4, so kind of going backwards to check our answer, of course the tangent of pi over 4 should end up being 1, but so should the tangent of 5 pi over 4. Because in the third quadrant, the y-coordinate negative root 2 over 2 divided by the x-coordinate positive root 2 over 2, negative over negative, excuse me, I said negative over positive. It's negative over negative, which does in fact also equate to 1. So keep that in mind. Your calculator will only give you one answer, and that will be pi over 4. All right, moving on. Example 3. Use a calculator to evaluate the following. So in this particular case, the inverse sine of 0.5524 is something that you can type in, noting that because 0.5524 is between -1 and +1, if we type this in, we will see a decimal, and in this case, because it's in radians, we'll decipher as such 0.5825. And if you recall, we can convert radians to degrees by multiplying by 180 over pi. So if we did in fact want to do a conversion just to kind of confirm where we're looking at this particular angle in context, in fact 33.53 degrees in the first quadrant is what we're looking at. So, next question, the tangent or inverse tangent, pardon, of negative 3.254. We'll go ahead and double check on the calculator. As you can see, I'm getting a decimal of negative 1.2726. The inverse tangent is something of which, when it comes to a decimal, you can get, with any number plugged in technically, you can get an answer of which is going to work. It's always defined at any value plugged in as far as a ratio. The output is restricted. Okay, so if we were to do the inverse tangent of negative 3.254, the answer is restricted between negative pi over 2 and positive pi over 2. And as far as converting, why don't we show that as well real quick here. This particular angle in degrees, if we convert, is, well, let's see, we'll end up here with negative 72.9 degrees. It is worthwhile to kind of keep in mind what angle and in fact what quadrant we're looking at with regards to your final answers. Speaking of which, if we were to go ahead and just kind of confirm here by virtue of the graph, you can see here I did an extra step or two of analysis. Looking at the graph, we can plainly see that negative 72.92 degrees is this angle here. It is also vertical and congruent to this angle here in the second quadrant. The angle, when it comes down to figuring out specifically the coterminal of which is positive, we would say 107.08. Coterminal meaning, again, with regards to this reference angle. Technically, again, that calculator is only going to give you this answer as it should, but we also need to know that the tangent of 107.08 is also going to have the same exact tangent. If you were to check your answer, that would obviously work. It turns out, again, only the answer we see here speaks to the radian value, that is, speaks to an angle between negative pi over 2 and positive pi over 2. So if we continue, compositions of functions, there is something to be said about when we did inverse work in a prior section. F of f inverse of x, but also f inverse of f of x in both instances equal x, if in fact it's an inverse. Now if we don't have inverses to start with, we can't make this this value statement. It is true though, again, that when you do the inverses, and if in fact they are inverses, that this is the case. So as we continue here, let's take a look. The inverse properties of trigonometric functions speak to, again, a restriction of x being between -1 and 1, and therefore yielding an answer for y between -pi/2 to +pi/2. We know we're discussing or referring to the inverse sine function. Can only plug in a number of a ratio for inverse sine, of which is between these two numbers, and the answers are restricted between these two numbers. So as it turns out, the sine of the inverse sine of x will then be equal to x, and then as you can see, the other composition, kind of going back to this idea, this premise, the inverse sine of the sine of y is equal to y. Okay, so it's similar to saying x is a result of finding the composition of an inverse with its original and vice versa. This is again resulting in x, while this is resulting in y. Now be careful, x is the same x from the domain restriction, while y is the same y from the range restriction. Notice the difference in compositions. That's important. Similarly, the same with x between -1 and 1 with inverse cosine, but y between 0 and pi. Cosine of the inverse cosine of x is equal to x, so it must fall between these two. And the inverse cosine of the cosine of y is equal to y, so in between those two. If x is a real number and -pi/2 is less than y, which is less than pi/2, then the tangent of the inverse tangent of x equals x, and the inverse tangent of the tangent of y equals y. So again, relating back to all reals with x, and between -pi and pi/2 and +pi/2 with y. This is something to be very mindful of anytime you're doing an inverse of which has a composition involved. So for example, we'll start off with the following. We'll say that sine of the inverse sine of 0.12. Now we're going to type this in to confirm. The calculator will do this whether you're in radians or degrees. So if we were to type in the sine of the inverse sine of 0.12, regardless of the mode, you're going to end up with 0.12. And if I did that in the other mode, so I did that in radians, let's now do it in degrees. If we do it, the result, if I hit second enter, and then just literally hit enter, let the calculator do its thing, you're going to end up with 0.12. The reason why the answer is just that in both instances, you're finding what angle has a y coordinate of 0.12, and then you're asking the sine of that angle is what? Well, it has to be, in this particular case, again, because it falls between -1 and 1, which is good, the answer just ends up being the angle, or pardon, the ratio in question. So you start and end with the same value is the idea, as it states here. The answer is just x. So for part B, similarly, accept notes, and I'm going to uncover everything here. This is a tangent problem, technically an inverse tangent of a tangent. So because we're doing the inverse tangent of y, technically the answer should just be y. Here's the problem. 5pi/6 is not between -pi/2 and +pi/2. And the picture off to the right kind of helps us denote this. And there's a whole litany of restrictions to play into this as well. So I've actually denoted that right here. -pi/2 is not less than 5pi/6, which is not less than pi/2. 5pi/6, as you can see in the picture, is in the second quadrant. While, however, if you look at the fourth quadrant, -pi/6, which is a vertical angle congruent to this pi/6 angle, will have the same tangent. So if you were to type this into your calculator, in fact, -pi/6 will be the result because -pi/6 does fall between -pi/2 and +pi/2. So in the end, the calculator will only give you one answer, -pi/6. Be mindful that although 5pi/6 is technically true, it is in fact an angle that has a y divided by x that is equivalent to this y divided by x in the fourth quadrant. It does not technically fall between the values that we see up above. We will continue this on our live day, but please look in advance on the completed answers for the notes so we can have a nice in-depth discussion in advance.